What if you could write a piece of software just one time and have it run on your PC, your Mac, pretty much any computer without changing a single line of code? Today that kind of sounds normal, but it used to be pure science fiction. We're going to talk about the language that made it a reality, Java. Let's break down the brilliant ideas that turned it into a global powerhouse. This phrase right here, this is the soul of Java. To really get how revolutionary this was, you have to imagine the absolute headache for developers before. You'd pour months into building something for Windows, only to have to start all over again for Mac and then again for Linux. It was a nightmare, so slow, so expensive. Java's promise to write once, run anywhere wasn't just some neat feature, it was a complete game changer. And that's the million-dollar question, isn't it? It sounds like it should be impossible. How could one program possibly speak the native language of so many different machines? Well, the answer isn't magic, but wow, is it clever. And the secret is this amazing piece of engineering called the Java Virtual Machine, or the JVM for short. This is the engine under the hood that makes that whole run anywhere promise actually work. Okay, so here's how it works. When a developer writes their Java code, it doesn't get compiled directly into the language of a Windows PC or a Mac. No. Instead, it's compiled into this intermediate, universal language called bytecode. You can think of this bytecode as a set of instructions that any Java engine on any device can understand. And this is where the JVM comes in to do its thing. See, each operating system, Windows, Mac, Linux, has its own specially designed JVM. This JVM acts like a personal translator on the spot. It takes that universal bytecode we just talked about and translates it line by line into the specific native instructions that the local machine gets. So the bytecode stays the same, but the translator is a local expert. That's the secret sauce. So that's the magic of how Java runs anywhere. But what about the philosophy behind writing the code in the first place? To get that, we need to dive into a concept that is at the very core of Java, object-oriented programming, or OOP. The central idea in OOP is the class. And honestly, the best way to think of a class is as a blueprint. Let's say you were building a house. You'd start with a detailed blueprint that defines all of its properties. How many rooms, the size of the windows, the type of roof. The blueprint isn't the house itself, it's the plan for the house. And that leads us perfectly to the object. If the class is the blueprint, well, the object is the actual house. It's the real thing you build from that blueprint with all the properties and behaviors that the blueprint defined. And just like a real blueprint, you can use that one class to build a whole neighborhood of unique objects. Now, this whole blueprint and object approach allows for some incredibly powerful ideas. You've got encapsulation, which is basically bundling all the related stuff together to keep your code nice and tidy. Then there's inheritance, which lets you create a new blueprint based on an old one, which saves a ton of work. And polymorphism allows different objects to do the same basic action, but in their own special way. It's all about creating code that's organized, reusable, and just makes sense. Okay, so we have the engine and we have the organizational blueprint. But what did this actually look like out in the wild? For that, let's take a little trip back in time to one of the first things that made people browsing the early web just stop and go, whoa, what is that? The Java applet. An applet was a little Java program that ran right inside your web browser. Now you gotta remember, back then, most websites were just static pages of text and maybe a picture. Applets were a revolution. All of a sudden, you had moving animations, little games, calculators, all running right there on the page. It was really the first taste of the dynamic, interactive web that we totally take for granted today. Now, what's really fascinating is how organized these little applets were. They had a complete built-in life cycle. It was like they had their own little lives. They were born once within it, they could start up, and they could stop to save resources. When you minimize the browser, they would paint themselves onto the screen, and finally, they were destroyed when you closed the tab. A tiny, self-contained application living right inside your browser. And inside that paint method, developers had this awesome graphics toolkit. They could draw text, shapes, lines, you name it. They could even fill those shapes with color. This is exactly how those early dynamic web experiences were built, just by telling Java what to draw and where to draw it. But drawing static shapes is one thing. How do you make an application actually respond when a user clicks a button or types something on the keyboard? Well, that brings us to our final core concept, Java's event handling system. The system is actually beautifully simple when you break it down. You have event sources. These are things like buttons that can create an event. And then you have event listeners, which are little pieces of code just waiting to react to those events. The key is you have to connect them. You tell the source which listener is paying attention to it. So here's a super simple example. You click a button. The button object, that's the source, creates something called an action event. It basically sends out a little signal saying, hey, I was just clicked. And the action listener, the code that was registered to listen, catches that signal and then does whatever you told it to do, like submitting a form or changing a color on the screen. All right, let's put all the pieces together now. We've seen the platform that lets it run anywhere, the philosophy for how to build it, and the system for making it interactive. So how do these three pillars combine to create Java's incredible, enduring legacy? Well, it's this beautiful three-part system. The Java Virtual Machine, the JVM, gives you the absolute freedom to run on any platform. Object-oriented programming gives you a powerful and, frankly, logical way to structure your code. And the delegation event model gives you the tools to make that code totally interactive and responsive to the user. These fundamental ideas are the reason Java has been so dominant for decades, powering everything from huge enterprise systems to, the billions of Android phones in pockets all over the world. It all comes back to that one simple promise. Which leaves us with a final thought. In a future with countless connected devices, what new worlds will Java's run-anywhere philosophy conquer next?